In this paper, we look at how an everyday robot can generalize its execution knowledge when executing common actions with different objects, for example grasping or putting objects in a drawer. In general, a robot will only have experience with a limited number of objects at design or deployment time, but will have to generalize its knowledge throughout its lifetime. However, execution failures are likely to occur when generalizing execution to new situations, as objects differ in shapes and physical characteristics. To avoid such failures and learn from them, a robot should know why it has made certain generalization decisions, but should also be able to realize that sometimes extra learning may be needed. For example, if the robot has only manipulated round objects, it will not necessarily be able to manipulate an elongated object, such as a banana. We present a method that guides generalization by using known relations between objects, as encoded in an object ontology, but augments those with the robot's execution experiences in order to reinforce or inhibit generalization between objects. We achieve this by annotating links representing object relations with probabilities that indicate how appropriate certain generalization is. We encode this by a so-called suitability graph, which combines an ontology with the robot's own generalization experiences. In the simple example shown here, a robot that needs to grasp a baseball is likelier to succeed if it reuses its experiences with a tennis ball rather than those with a rugby ball, as a baseball and a tennis ball are more similar both in shape and in physical characteristics. We evaluate our method with two actions, grasping everyday objects and throwing them in a drawer. In both cases, the robot first learns individualized models for a few objects and then attempts to generalize the models to other objects. Wherever possible, the generalization is readjusted based on execution failures. Our proposed framework uses an ontology as prior knowledge that guides how actions are generalized between objects, but augments the graph of relations with the robot's own experiences. This results in an adaptive and explainable generalization scheme that is suitable for lifelong learning and can benefit from direct human feedback.